All right. So we have 0.113 molar sodium sulfate, so that means it is 0.113 moles per liter. And we want to produce 0.668 grams of barium sulfate. Something that I find is helpful at times is to make a note, who are we trying to find or what's going on within this. So what do we have? We have 0.668 grams of barium sulfate. That's what we have to start with. We're trying to find what? Milliliters of sodium sulfate. This is who we're trying to find, is milliliters of sodium sulfate. But we have grams of barium sulfate. What are we going to use to find volume? Molarity. You're going to use molarity. So in this case, comparing this problem to the problem above. In this problem, you started with volume and you use molarity immediately as a conversion factor, or very quickly as a conversion factor. When will you use molarity as a conversion factor in this problem? The second one. At the beginning or the end? Towards the end. Towards the end. You're going to be using it towards the end, because what are you going to use this to find? Liters, volume. You're going to use this to find volume. So what do you start with? And guys, I gave you a big hint. 0.668 grams barium sulfate. What was the hint that I gave you? What did I do on the paper to tell you, start here? I underlined it. Do you see that? I underlined it. I tried to make things easy for you. I underlined it. Problem is maybe I don't explain my method. I just assume, which is not good, that you'll figure it out. So, 0.668 grams of barium sulfate. So where are we going to get this information? Today in this problem, where do you get this information? I gave it to you. Do you need to go calculate this from the periodic table? If I give you molar mass, use the molar mass I give you. So 233.40 grams per 1 mole of who? Barium sulfate. So grams of barium sulfate cancel, and what are we now in? Moles of barium sulfate. But what do we want to be in? Who, maybe I should say, who do we want to be in? Good job. So what's the mole to mole ratio? Now, I did not tell you that this was balanced, but you probably realized it is balanced because of the 2. Thank you. Good. So then what goes on bottom? 1 mole of who? Barium sulfate. Who goes on top? 1 mole of sodium sulfate. Good job. 1 mole of sodium sulfate. So moles of barium sulfate cancel. You're in moles of sodium sulfate. And what do you want? What do you want to know about sodium sulfate? Milliliters. So what conversion factor did I give you that deals with volume? Molarity. What is the molarity? No, what's the molarity? 0.113 what? Moles per liter. So where does 0.113 moles go? On the bottom. So 0.113 moles of sodium sulfate in 1 liter of sodium sulfate. Now, I shouldn't have marked off sodium sulfate because you are still in sodium sulfate. So you still are sodium sulfate, but you don't want liters of sodium sulfate. You want what? Milliliters. So how many milliliters in a liter? So 1 liter is 10 to the 3rd milliliters. So run your numbers. How many significant digits do you need in your final answer? 3. All right, so what's your final answer? 25.3 milliliters. And you can just leave it like that. It is really 25.3 milliliters of 0.113 molar sodium sulfate. And that may be how I will write the answer on your test, but for right now, you could just leave it as 25.3 milliliters. Okay? Questions on that? Does that make sense? Is it making sense? All right, the next one. I gave you the balanced equation after we talked about it. I mean, that's the last thing we did. We figured out the balanced equation for this neutralization reaction. In 107, whether you take it in the summer or the fall, you should be starting on acids and bases. That's what you should be starting on when you start 107. I haven't taught 107 here in a long time, so I'm not 100% sure that's where they start, but that's where they're supposed to start. So this problem, dealing with neutralization, is something you will be doing in 107 at the beginning, and then the rest of 107, there'll be probably a little bit of nuclear chemistry in 107, and then the rest of 107 is organic. That's the majority of your time, is organic chemistry for 107. But if we look at this problem, for those of you who have to take it, some of you don't. The ag majors have to take 107. I'm not sure that those of you that are construction management have to take it. But if you look at this one, what you're going to see is that we start with what? What are we starting with for this problem? Where do we start and what is our end? Maybe let me ask a better question. Who are we starting with? What substance are we starting with? I hear two different answers.
Sodium hydroxide.
You do not start with sodium hydroxide. Why not? It's asking how many milliliters of sodium hydroxide. So what are you going to end with? Who are you going to end with? Sodium hydroxide. This is the end. This is the start. Not necessarily that number, but I'm saying this is who you start with. This is who you end with. So once you figure that out, then go back and say, what number do I start with? And you should be able to figure that out based on another problem we've already done on this page. Tell me. What do you start with? 8 milliliters. That's exactly right. So you start with 8 milliliters of H2SO4. What are you going to convert 8 milliliters to? Liters. So 10 to the third milliliters in 1 liter. You're still H2SO4. Milliliters cancel. Go ahead, Lucas. What do we put? Perfect. 3.5 moles of H2SO4 over 1 liter. Good job. So 1 liter cancels out. Now what are we ready for? Ding, 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 ding. Mole to mole ratio. Mole to mole ratio. So what goes on bottom? 1 mole of who? H2SO4. What goes on top? 2 moles of who? Good. Moles of H2SO4 cancel. You end up with moles of NaOH, but your answer is not wanting moles of NaOH, it wants milliliters. So are you going to do the opposite now of what you did at the beginning? Does that make sense? Good, good. Yes?
Why can't you just...
Hold on, okay, hold on. Let's finish it, then see, okay? Hold on a minute. So what goes on the bottom? Who? 2 of who? So 2 moles of NaOH. What goes on top? 1 liter. Who is that still? NaOH. So moles of NaOH cancel. Now you're in liters of NaOH. Now what? What do you want to be in, folks? So what goes on bottom? 1 liter and 10 to the third milliliters. It's still NaOH. Now, are there things that will cancel out? Yes. Yes. So this will cancel, these 2's will cancel. So in essence, by the time you're done, you're really only multiplying 8 times 3.5. So what's your answer? What's your answer? 28 milliliters of what? Sodium hydroxide. And again, properly, it would be 28 milliliters of 2.0 molar sodium hydroxide, because that molarity makes a difference. Now, did you get your question answered, or do you still have a question? Huh?
Why can't you just take 3.5 moles and use the molarity of the 2.0 and just change it to moles right there? Like 3.5 moles and we put 2.0 moles on the bottom back and we do it with NaOH.
You're trying to do like a dilution problem? Is that what you're saying? It's two different substances.
So why do you have to balance?
Why do you have to have a balanced equation? Because this is different than that. I think, and you can show me later, I think what you're trying to do is a dilution problem. Like C1V1 equals C2V2? No? Well, show me later. Can you do that? Okay. Do you understand why this is the setup? Okay. All right. What's your next question, or the next question on right here? Tell me the difference in this one than anything else we've done. What are you trying to find at the end? Molarity. You haven't had one that you tried to find molarity for. Again, what's the formula for molarity? Moles over liters. Moles over liters. So you need to make a note to yourself, molarity equals moles over liters. Who are you trying to find the molarity of? Say it one more time. Acetic acid. Who is acetic acid? And the volume is what? 25 milliliters. Did you hear what was happening? So who are you trying to find the molarity of? Tell me again. Acetic acid. How much acetic acid do you have? 25 milliliters. So molarity of acetic acid is going to be moles of acetic acid over what? Tell me how to get 25 milliliters into liters. 25 divided by what? 10 to the third. So what's the answer going to be? You can write it. You can do a little side problem if you need to do that. So yeah. But I'll go ahead and write it down here just so you have that. And then that's going to go up there. So it's going to be 0.0250 liters. So where is this moles going to come from? Where is that moles of acetic acid going to come from? Well, what do you have to do? What are you going to use now to solve to get moles of acetic acid? What are you going to do? What are you going to start with? 15.5 milliliters. But what do we have to have before we can do any of this? A balanced equation. You've got to have a balanced equation. You must have a balanced equation. So somewhere you have to. Now the question is also, why do you have to have a balanced equation? How do you know you have to have a balanced equation? How do you know you must have a balanced equation for this problem? Two different substances. You're going from acetic acid to sodium hydroxide, or sodium hydroxide to acetic acid. The only way you can do that is with a balanced equation. Sodium hydroxide is your base. Acetic acid is the acid. And so it's neutralizing, in other words, making them basically form water is what you're looking to do, is making them form water and a salt. So this is a double displacement reaction. Same thing we've done in class when we did double displacement reactions. It just is written differently by calling it a neutralization reaction. So it's NaOH plus, what is acetic acid? Good job. HC2H3O2. Very good. I love it when you all know your polyatomic ions. HC2H3O2 yields what? I told you what one of the products was going to be. NaC2H3O2. So that's sodium acetate, NaC2H3O2 plus water. And I'll write it as HOH. Now, how did you know it was NaC2H3O2? Some of you just said, oh, it's there's C2H3O2, there's Na, but you're not thinking enough if that's all you did. Well, you know it's a double displacement reaction, yes, that was even a precursor, but how do you know it's exactly NaC2H3O2? What's sodium's charge? +1. What's acetate's charge? -1. Okay? You have to balance the charges. Then what do you have to do? Balance the whole thing. Then you have to balance the whole thing. So then you go 1 Na, 1 Na, 1 OH, 1 OH, 1 H, 1 H, 1 C2H3O2, 1 C2H3O2. Is it balanced? Yes. All right. So now go ahead and tell me again where to start. So 15.5 milliliters, and I'm actually going to do it down here to leave this space so that I can put moles in there in a minute. So I'm going to do 15.5 milliliters. Who is this of? NaOH. Now, what do I do next? Good. So 1 liter on top, 10 to the third milliliters on bottom. Again, this is still NaOH. Milliliters cancel. Keep going. You got it. What goes on top? 0.20 moles of who? NaOH. What goes on bottom? 1 liter. That's the molarity. I'm going to make a little note here just as a reminder. That is the molarity given in problem. Go ahead. I heard it. Say it again. Mole to mole ratio, which is going to be 1 mole of NaOH with what? 1 mole of HC2H3O2. Mole and NaOH cancel. I'm now in moles of who? HC2H3O2. Who do I need? Moles of acetic acid. Is that what I need to plug into molarity? Yes. So now get this answer. Can you round that answer? No. Good. So you should get 0.0031 moles of HC2H3O2. But that is not your final answer. What's the question asking for? Molarity. So what do you do with this? So you plug it back in up here, 0.0031 moles over 0.0250 liters equals, and round it to proper significant digits, which would be how many? Go ahead, how many? Go back to original problem. Look at the words. 2. 0.20 is 2. 0.20 is 2. So what's my final answer? 0.12 molar acetic acid. Or you could have put 0.12 moles per liter. It doesn't matter. Either one. Talk to me. Does that make sense?
Yes.
All right, so you have several different kinds of stoichiometry problems on this page. There's several different kinds. Several different ones here. Does it make sense what we're doing? I would strongly encourage you to redo all these on this page. Just redo them all to make sure that you can do them without me doing it first. because I think that will help you to be able to do that.
And then what about the practice on the back?
We're going to do it. Let's look on the back. Okay? All right, so flip it over. And this is not by any means all inclusive. This is some more practice problems. This is just more practice problems to help you. Okay? And they're all mixed together. This would be more like what your test might look like, and this I mean, your test is multiple choice, but I'm just saying it's all mixed together. And you don't necessarily know, I mean, here I tell you what to use. I won't do that on the test probably. I won't say it again? You still need to show your work on your test. Yes, you still need to show your work on your test. It's probably more important to show your work on this. I mean, it's always important to show your work on this test. But one reason that it's extremely important to show work on all tests, and especially the final exam, is you guys have the opportunity to look at your old test. If you don't take that opportunity, that's on you. But on the final exam, if I have a student who is, let's say that they are 78.1, that's their average at the end of the semester, then oftentimes what I will do, especially if it's a student that I know has been here pretty much every day, what I will do is I will go back and look at their final actual exam and see if I can find where they made a mistake somewhere. And if I can find a few points to help them get that B, or in that case, yeah, a B, okay, or whatever the grade would be. I don't do it if you're lower than that probably, because usually you're not going to gain enough. But a lot of times I'll have students that don't write anything on the test, they don't circle any answers, and they bomb it, and there's nothing I can do. Because if you don't write on your test, there's nothing I can do to help you, okay? So I would encourage you always to write on the test, always, okay? All right, so what do we do on this first problem? So how do we do it? Now I'm going to tell you something. You need to do something different on this one than we've had. I don't think I've given you a problem like this exactly before. What's the formula for mass percent? First of all, let me just say something. I have not given you a problem exactly like this, period. Because we didn't have just mass percent. What did we have as far as, and this was pulled from another handout, so this is a little bit different, but you should be able to figure it out. What did we have as far as calculation formulas for concentration? What were the two we had at the beginning? Mass what? What was it called? Mass volume percent. We had mass volume percent, and we had volume percent, and we had parts per million. What was parts per million? Was it mass over mass or volume over volume?
I mean, solution times.
Right. So, but it was still mass or volume. What do you think I mean by this one? Which one is this? Is this a mass volume? Or is this closer to parts per million, except we're not multiplying it by 1 million, we're multiplying it by 100? Yeah, that's exactly right. That's what this is. Mass percent would be the same thing as parts per million or parts per thousand or parts per billion, except instead of multiplying it by 1 million, 1 billion, 1,000, you're multiplying it by 100. Because mass percent is the same thing as parts per 100. Okay? So it's going to be, and Ryan said it right, it's mass percent is mass of solute over mass of what? Look at parts per million and tell me what it says. Mass of solute over what? Mass of solution. Mass of solution times what? 100. Now, there's something special about this that you better pay attention to. Not special, tricky. Say it again.
It's the full solution.
It's the full solution. What have I given you? I give you.
So it's 72.7.
How did you get that?
Adding them together.
So what? Tell them why you did that.
Because you have to have the full solution, and it just gives you two separate parts to build a solution.
That's exactly right. It gives you the solute, and it gives you the solvent. Does that make sense? So what do you have to get the solution? The mass of both. Do you follow what I'm saying? This, you have not seen this before. You may see it on your homework. Did you see it on your homework, Brittany? Was there? I thought so. That's exactly what I thought. I thought there was one like that on the homework. That's why I wanted you to pay attention on this. Because on the homework there is one, at least one, where it gives you the solute, it gives you the solvent, but you have to add them. And it may not be, I don't know if it's a mass percent or if it's a volume, I don't remember. But regardless, you've got to pay attention. This is solution. So what's the solute? 33.2 grams divided by, and I'm just going to make a note here, 33.2 plus 39.5, and you said it equals what? 72.7?
Yeah.
So 72.7 grams, and we multiply that by 100. So what do you have for your answer? 45 point what? 7%. Talk to me. Okay. All right, tell me what to do on this other one. Tell me what that 15% means. Now, on this one, and I will tell you I should have said more of what this one is, and I didn't. So let me say this now, because I realize there's missing information here. Do you may want to tell me what's missing? What do I not tell you?
What the solute is.
Well, you know what the solute is. Read that again. You do know who the solute is. Who's the solute? Silver nitrate's the solute. And what you all don't have the knowledge of is how would you make a solution of silver nitrate? That you don't know. You would make a solution of silver nitrate in water. So then what you don't know that I should have said is that this is 15% mass volume. Why is it mass volume and not mass? Because it's the mass of the powder silver nitrate in what? Water, which is the liquid, which would be milliliters, okay? And that I should have told you. I should have put MV or WV, weight volume or mass volume, same thing. I should have said that, and I didn't. So now that I've told you that, what can we use this as? There's two different ways you could do this. You could do it as an algebra problem. I don't like doing it that way. I prefer dimensional analysis. What, if I use dimensional analysis, how will you write this? How would you write this? Say it, you're right. 15 what? Grams per 100 milliliters of solution, yes? So 15 grams of silver nitrate, is that right? Per 100 grams of solution, that's what that means. So what is the 257 grams of? The solution. That's exactly right. It says it. What mass of solute, so we want to know how much sodium nitrate, or silver nitrate rather, is present in 257 grams of solution. So what do we start with? 257 grams of solution, SOL'(N) is solution. I encourage you to write that. And if you had set it up this way, what does that also say? What do you do next? What do you put on top? No, what do you put on top, guys? Or, I'm sorry, you're right, Lucas. Sorry, you're right. Say it again. I'm wrong. Say it again. 100 milliliters, good job. 100 milliliters of solution, what goes on body? Correct. 15 grams of, wait a minute. This must be a mass. That does not make sense. You know what? It is a mass. It has to be. I couldn't have asked the question that way. It is a mass. How do I know it's a mass? Because I would have been given milliliters. I would have been given milliliters had it been a mass volume. Sorry, that's my wrong. On recorded, I am wrong. That is not a mass volume or a weight volume. It is a mass. My wrong. So that means it's 100 grams of solution. Unusual to do it that way. Not sure why I did do it that way, but that's what it is. It's 100 grams of solution, which means scratch all that out. And that's why I kept hesitating when I heard Luke. I knew what the order should have been when I heard Lucas say that. I'm like, wait a minute, that's not right, because that's not. So totally wrong there. So start again, 257 grams of solution. Now what goes on top? Still, what goes on, or now, well, no, not still. What goes on top now? Who are we trying to find? 15 grams of silver nitrate in what? 100 grams of solution. Do you follow why I'm wrong?
Yeah.
So grams of solution cancel. Now we're in grams of silver nitrate. What do you get for your final answer? How many significant digits would be what? Go ahead, say it again. 38.6 what? Grams of who? Silver nitrate. Yeah. Let me ask this question. This is just to see if you really understand concentrations. If the solution had been 40% silver nitrate, would this number be more or less? If this 40%, would this number have been more or less? More. In other words, if it were a more concentrated solution, would you have more solute?
Yes.
Yes, that makes sense, doesn't it? Okay.
Because the top number would be higher.
Exactly, because this would be 0.4, or this would be 40 rather instead of 15. Okay? All right. Now, tell me what the formula, basic formula for this one is. Mass over mass times 1 million. Yes or no? Mass over mass times 1 million. It doesn't have to be grams over grams. It doesn't have to be milligrams over milligrams. It doesn't have to be kilograms over kilograms. It just has to be the same unit. What are you going to do? Say it, Lucas. What are you doing?
Convert one of the masses.
Does it matter which one you do? Either make them both milligrams, make them both kilograms. It does not make a difference. They just have to be in the same unit. So convert them both to milligrams or convert them both to kilograms, okay? Try that. I'm going to be quiet and let you do that one. This one's not a hard one, okay? Convert them both to the same unit. Now, there's something else you have to do. Have you paid attention? What else do you have to do? What is parts per million? Is it mass of solute over mass of water? So what are you going to have to do? You have to add these together again. Look, do you see where it says water? And this says potassium chloride, so what do you have to do? You have to add them together. You have to add them together, okay? Because water is not the entire solution. Now, it's not a lot different, but water is not the entire solution. Have an answer? Let me ask you a question. If you're doing a problem that's in parts per million, do you think you would end up with a really big number or a small number? Small number. If it's a parts per million, chances are you're going to still end up with a small number because you would not be using parts per million if it were a big number. What might you be using? Parts per thousand or parts per 100%? If it was a high concentration, then you would be using parts per 100, which is percent. This is not a big number. You should not get a big number. What do you get? Rounding to the proper significant figures, what do you get? 2.67. You should get 2.67 ppm KCl. 2.67 ppm KCl. That's what you should get. Do you get that? Now, if any of you do I have anybody in here who has ever checked pool water? Anybody in here ever checked pool water? Okay. What do you want your chlorine level to be? Anybody know? Between 2 and 5 parts per million. Now, think about that. Is that a small amount or a large amount? Small. Look at this. 0.00004 kilograms, which was 40 milligrams. Do you remember using your balance in lab? Do you remember using the balance in lab? When you would just get 1 gram of something in lab, was that a small amount? 1 gram was a small amount. This is 40 milligrams. 40 milligrams would be a very small amount. 40 milligrams is a very small amount. Is this a lot of water? 15 kilograms of water? 15 kilograms of water is hold on, I'll tell you, I'm not using my brain very well right here. About 33 pounds of water. 15 kilograms is about 33 pounds of water, okay? So 40 milligrams, you've seen a gram, you've seen 2 grams in lab, not much at all, and 33 pounds of water. Follow me? 1 gallon of milk is about 8 1/3 pounds. Now you with me? So how many gallons would this be? Okay, 5 or 6 gallons of water, yes? So a 5-gallon bucket, is that, so now, does that give you an idea of how little parts per million is? And when you think about it though, do you want it to be that? Do you want it to be a little bitty amount if you're in the water? Yeah, you don't want it to be much. You don't want it to be much at all, okay? All right, so now go to the next one. A quantity of 3.5 moles. This is the easiest one we've done so far. This one's a piece of cake compared to what y'all been doing. What are you doing in this problem? The only thing you're doing is what?
206.75 milliliters.
That's it, and then doing what? Moles over? That's right, that's all you're doing. It's a simple molarity problem. So what do you get?
5.1.
Molar. Very good. 5.19 molar. Everybody get that?
Yep.
All right, keep going. You should be able to do the next, actually, why don't you just try the next 3 problems? I'll wait for you. We should be able to finish all 3 of these today. And you're done. You can sing and shout for joy. Get all 3 of them, guys. Where I wrote M1V1 equals M2V2 here, that is just molarity 1, volume 1, molarity 2, volume 2. We wrote it as C1V1 equals C2V2. Concentration of 1, volume of 1, concentration of 2, volume of 2. It's the same exact thing, except here I just said it's molarity. But it can be any. Don't forget, you need the same unit here. This one is in milliliters, that one's in liters, so make sure you notice that. You have had a problem in your notes exactly like this bottom problem. You've got it on the previous page. So I'm going to be quiet and let you do it. It's important that you know how to do these without me doing them. Call out if you have a question, but I think you need to try it by yourself and then ask me and then work your way through it by looking at your previous problem. Say that again? Sig figs at the very end, yep. Are we ready to look, guys? The answers? What's the answer to this problem? $93.4 milliliters, good. And this one? 8.24 what? Molarity, or molar, 8.24 molar, good. All right, did everybody get those two problems? Those are the easy ones. Are these problems that you could just plug that number back in and see if you get the same answer on both sides so you know you got it right? There's no reason not to get these right. Okay, no reason. All right, where do I start with this problem? What's my first thing I write down? 25 milliliters of who? HCl, good. And then convert that to, good. It's still HCl. Now what? 2.50 what? Moles of HCl over 1 liter. Yes or no? Okay, so liters cancel. Milliliters had canceled. I'm in moles of HCl. Now where's that coming from? Right there, good. Balanced equation. Mole to mole ratio, so 16 moles of HCl. Keep going. 2 moles of who? Potassium permanganate. Can't write. KMNO4. Good. So moles of HCl cancel out now. I'm in moles of KMNO4. And now I what? Stop and get what? Moles of KMNO4. Why do I stop and get moles of KMNO4? Because what do I need? So molarity equals moles over liter. Yes or no? So this answer is going to go right there. Talk to me, folks. Do you get 0.0078125? Moles of KMNO4. And that goes here, so 0.0078125 moles. And what goes on bottom? Good job, because it's this volume converted to liters, so 0.0387 liters. Yes, no? And how many significant figures? Go back to your original numbers. What will that be? So the answer is 0.202 molar, or you could put mole per liter KMNO4. Folks, look at this problem right now. Look at this one. For those of you that did not get this done, finish this up, although I really think you better do this page again. If you only do what I've done in class, you will not do well on this test. I will also say, many, many years, I have had students do better on this test than they do on any test, if you like math, because this is a pretty much math test. But if you don't practice, you won't do it. You won't do well. You got to practice, okay? Now, look at this problem. Now, flip your page back over. Was this problem the same as that problem except different numbers and different balanced equation? Guys, there's no reason you shouldn't have been able to get that last problem. This problem was done for you. You have to learn to use what you have in front of you. And now go back and do everything again on your own if you want to do well on this test. Okay? All right. Do you have questions before we leave? Any questions? This is your chance. Before you leave, wait just a minute. Let me look at something. Before you, don't get up and don't start moving, please. I want to confirm for you something. Your final exam is when? April 30th, what time? 1 o'clock in this room. Okay? April 30th, 1 o'clock. All right. You probably won't be able to hear this, but I'll see if you can. Whoops, it lost it. Hold on a minute. Come on, buddy. What did I do? Pick the instrumental one? Is it not it? This is Kenny Loggins. Is it Huey? She knows everything, so I don't doubt her. Oh, here it is. You're right, McKinley. You always are right. When it comes to music, she's always right.
Members get more, earn more, and save more. And
Shut up.
cardholders save the most.
I got the commercial. I can't help it, okay? It's a commercial. I can't help the commercial, McKinley.
Sign up for JCPenney Rewards today. JCPenney.
Shut up.
Enjoy the next 30 minutes of uninterrupted listening.
Never mind. I should have had her do it for you because I can't. Bye, guys. Have a great day. See you next Tuesday. Lucas, just come down here, buddy.